Hi, my name's Sophie. I am a maths tutor and founder of Tutor in a Box, and hopefully you are here today to learn more about Pythagoras. So this webinar is going to talk a little bit more about what it is, where it came from, and what you need to know for your GCSE exams. Whether they're next year, a couple of years away, or a couple of days away. Hopefully this will either recap what you already know or help you with new information. I'm going to be sharing a couple of the slides from the material we've shown and that's included in the boxes. And I'm also going to be using a whiteboard as well to talk through some key information. So first things first, what is Pythagoras? Pythagoras' theorem is a key topic in GCSE maths, okay? It relates to right-angle triangles, so non-right-angle triangles don't count, so just right-angle triangles. And it's about working out the side length of a triangle, okay? So if it's angles or it's a non-right angle triangle, nuh-uh, we're not interested. If it's Pythagoras, it's got to be a right angle triangle and it's got to involve the side length, okay? So that's the first thing you need to know. The second thing you need to know is that there's a magic formula for it. That magic formula is a squared plus b squared equals c squared. Okay, and this is really, really important. So learn this formula. Take 30 seconds to stare at the screen and learn it. Okay, so now you might be wondering what A, B, and C are. And that's a really good question. A, B, and C are merely the different sides of a triangle. So if we draw a triangle and we've got our right angle here, we can label our sides A, B, and C. The important thing to note here is that our longest side, C, to this one, is always, always, always opposite the right angle, okay? So C is always, always, always opposite the right angle. It's our hypotenuse. Okay? So you might have different questions or the triangles might look slightly different. So we're going to show you some examples of triangles and draw them on. So you should all be able to see the screen in front of me and we're going to draw some triangles and you can see what they look like. Okay. So the first step with drawing our triangles is joining up our three lines. Okay, so as discussed, if we have that right angle here in the bottom corner, then this length has to be C. That is our hypotenuse, it's our longest length. This length can be A or B, and the side left is just going to be the other one, okay? A, B, and C. I'm going to draw another triangle now, and I want you to see how you get on. Oh, that's not that's not straight lines. Let's try this again. Okay, I'm going to give you 30 seconds to have a look at that triangle. Which length is A, B, and C? Okay, great job. Hopefully you've had a go at this. So this length is going to be my C length. So that is the longest side. So here is my longest side and therefore my C length, which is my hypotenuse. I can then call the other side A and then the one left can be B. Voila, we've labelled them all. Let's have a go at one more. Okay, what about this triangle? We've just drawn in our right angle in the corner, and a right angle, remember, is 90 degrees. So let's have a go at labelling it now. Feel free to pause this webinar and label them A, B, and C. Okay, so hopefully you've paused it and you've had a go at thinking about which are our lengths A, B, and C. Now, hopefully you got this length as C. And that's because it's the side opposite our right angle, and it's the hypotenuse. The other side is A or B, and then the other one is the letter we haven't used. Voila, we've labelled the hypotenuse. Now we know that we've labelled them. Let's start adding in some numbers, and let's start recapping that formula. So, if we have a look at our triangle, okay, bit of a odd triangle here, but that's okay. Okay, so imagine you get given this kind of question in the exam, and it says, two lengths of a triangle are 4 centimetres and 6 centimetres. Find out the length of X. Okay, well, no problem. We know it's a right angle triangle, and we know that we've got two sides, and we want to find out the third side. So we're going to use Pythagoras' theorem. Pythagoras' theorem says that a squared plus b squared equals c squared. Now you'll notice on the whiteboard, I've put a -2, and that's just because we can't get the square signed up. But if I was to draw it freehand, it would look like a squared plus b squared equals c squared. Okay, so you'll notice that the notation might change as we go along, and that's just to make things a little bit neater. So where I've got that -2, it just means squared. Okay, so now we've got that, what are we going to do? Well, all we're going to do is label them A, B, and C. Well, if you remember, the one opposite the right angle is our hypotenuse, and it's our longest side. So that's going to be C. We can label the other sides A and B. Happy days. Now, let's have a go at working it out. So, we said our A squared plus B squared equals C squared is our magic formula. And I'm going to get rid of this top bit so it doesn't confuse anybody. Okay, so we've got our magic formula, a squared plus b squared equals c squared. So what's a? Well, length A is 4. So we're just going to do 4 squared. And then it says plus, and what's b? Well, b here is 6. So we're just going to pop 6 in instead of b. 6 squared. And that is going to equal c squared. Now, if we square 4, we get 16. So 4 squared is the same as 16. So on the next line, we can just put 16. Now, 6 squared is the same as 36. So again, we can put 36 on that next line. Now, if I add 16 and 36 together, I get 52. So I can just write 52 equals c squared. Now, I don't want to know what c squared is. I want to work out what c is. So this is when you need to grab your calculator. Bear with me. Okay, hopefully you've all got a scientific calculator that looks a little bit like this. What you're going to do is find the square root button, and on this calculator, it's this one here. So you're going to press it, and it's going to come up with that. We then pop in the numbers we want. So in this case, it's 52. We then press enter, and we get another number, which we can then change to a decimal, 7.211. So 7.211 equals C. And so now you found out the length of this side, which was X, which was the thing we wanted to find out, and the length of that side is 7.211, and that can be centimetres, metres, whatever units it was in to begin with. That's the first step with Pythagoras in learning how to use your A, B and C's. We're now going to look at what happens if you have them in a slightly different order. So maybe you're given C and you want to work out A or B. What do you do then? Let's take a look. So let's imagine you've got a triangle. Okay, so we're just going to move this triangle down a little bit. Okay, so we've got our triangle here. Let's label them. We are going to have this one as 8. Let's have this one as 3. And let's say we want to find out the bottom length, which is y. And again, our right angle is here. Now, how do we know it's Pythagoras? Well, it's a right-angled triangle, number 1. And number 2, we're only looking at sides. There's no angles involved. So we know it's going to be Pythagoras. Now we know our formula is a squared plus b squared equals c squared. So the first thing we do is write that down. Next, we're going to label the sides. So this side here is going to be C. Remember, our C is our hypotenuse. It's always the longest side and it's always opposite the right angle. The other ones are going to be A and B. So now we're just going to substitute those numbers in. So A squared is 3 squared plus B, but remember, we don't know what B is, so we'll just pop B in, which equals C squared, which is my 8 squared. Now here, you'll notice I've got my unknown, or my B, on that left-hand side, and I want to find what that is. So we're going to have to take away and move our 3 from this side to the other side. So we're going to have B squared equals 8 squared minus 3 squared. Now, this is another way of writing b squared equals c squared minus a squared. So let's write that down here. Ooh, that pen's gone a bit haywire. Okay, so we can see that b squared equals 8 squared minus 3 squared, and as we've said, that's just another way of writing our Pythagoras' theorem, but we've just changed the a onto the other side. If you need more help with algebra and rearranging things, then have a look at our algebra webinar that specifically goes through changing sides. So, back to the question. We've got our b squared, and that equals our a squared minus 3 squared. Well, 8 squared is 64, so we put 64 here. 3 squared is 9, so we just put our 9 here. That means b squared is 55. Then, to get the square root, we do b equals the square root of 55. Now again, we can use our calculators to do this. We press the square root sign and then we type in the digits 55. So it looks like that. We then press enter and then the S to D button if it doesn't come up automatically, and it gives us a number, 7.416. So B equals 7.416. So here, our Y value, which is our B value in effect, is 7.46. And that's all there is to Pythagoras. It's about remembering the two key facts. One, Pythagoras only works on a right-angled triangle. And two, it's only working out the side lengths. If there's any angles involved, so they tell you one of the angles is 32 degrees or one of the angles is 64 degrees, that's no longer Pythagoras, and it's likely trigonometry. Well, I hope you found this webinar useful, and hopefully it's gone over some of the information in your packs. If you've got any questions or comments, then do feel free to reach out. You've got my email and you know how to get hold of me. Otherwise, have a great day.